Hello, curious minds, and welcome back to the deep dive. Today, we're inviting you to, well, maybe fundamentally rethink the biggest story we tell ourselves, the story of how our universe began. For, gosh, over a century now, the Big Bang has really been the bedrock of cosmology, that one single explosive moment where everything just emerged. But what if that story, as powerful and familiar as it is actually just, one chapter in a much larger, way more intricate cosmic saga? Our mission here, as you know, is always to wrestle with these complex ideas, pull out the most fascinating insights, and give you a really solid, multifaceted perspective. And we try to do that without drowning you in jargon. So get ready. We're about to dive deep into some concepts that are truly mind-bending. They challenge not just physics, but maybe even how we define reality itself. Today's focus is the unified coherence theory of everything. Let's call it UCTE for short. And specifically, we're digging into how two really groundbreaking interconnected papers by Philip Lilien fit together. The first is the Coherence Emergence Event, and the second, which builds on it, is the Codex of Emergent Universes, Multicellular Big Emergence. We're going to explore how these aren't just separate works, but how they weave together to paint this, well, unified, dynamic, and frankly revolutionary picture of cosmogenesis, the universe's birth, its structure, and how it keeps evolving. And what's really exciting, I think, about this deep dive is seeing how that second paper just dramatically expands on the first one. It takes us from this idea of a cellular universe, our universe, as one cell among maybe millions,
to something much more organic, more like a multicellular organism
Yeah.
for the whole multiverse. It even introduces things like cosmic Coulomb barriers, think dynamic membranes and entanglement bridges connecting these cosmic cells.
Yeah, it's a profound shift. It's not just tweaking physics, it's proposing a fundamentally different kind of reality.
Exactly. So
I-
let's really unpack this. We're talking about a universe or maybe multiverse that isn't just one big bang, but potentially millions, maybe billions of these dynamic, interconnected creation events happening constantly, interacting. And this is where it gets really interesting.
It absolutely does. And that integration you mentioned between the two papers, it's key because you get this comprehensive view that's, well, revolutionary in its scope, but also quite elegant conceptually. The Coherence Emergence Event, the CEE paper, gives us the basics, the foundations of how maybe an individual space-time domain crystallizes.
Right, the building block. Exactly. But then multicellular big emergence, MBE, takes those individual cellular universes and really elevates the whole concept. It turns it into this almost biologically inspired model of a living, evolving multiverse.
Like moving from studying one cell under a microscope to understanding the whole complex organism.
Precisely that. It's that leap in scale and complexity.
Okay, so let's start by, well, shaking the foundations a bit. For 100 years, the Big Bang has been the origin story. It explains cosmic expansion, the microwave background, so much. But Lillien's first paper, CEE, kicks off by challenging the single story. It points to growing inconsistencies. So what are these cracks that are appearing in the standard Big Bang model? Are they just little blips, or are they fundamental problems?
That's a really critical question. Look, the standard model, the Big Bang plus inflation, has been incredibly successful. Let's be clear about that. It's still our best working explanation for many things. But it does face some growing challenges, especially as observational data gets better and better. The CEE paper specifically highlights anomalies that are, let's say, difficult to fully square with a single perfectly uniform origin event, even with inflation smoothing things out initially. Take the cosmic microwave background, the CMB. We see these localized fluctuations, these patterns.
The cold spots and things like that.
Exactly, the cold spots, but also other larger scale alignments or asymmetries that seem, well, statistically unlikely if everything started perfectly smoothly and uniformly inflated. They don't quite fit the picture.
Right, so they're not just random noise. They're structures, patterns in the afterglow that shouldn't really be there according to the simplest version of the story. How significant are these?
They're significant enough to make cosmologists uncomfortable, let's put it that way.
Sure.
We're talking about deviations that really push the standard model, requiring maybe some fine-tuning or extra assumptions. And beyond the CMB, think about the large-scale structure of the universe we see today. You know, the cosmic web, these huge filaments of galaxies, and the vast empty voids between them. They seem almost too organized, too big, too interconnected, to have just sprung from one initial undifferentiated explosion, even with gravity acting over billions of years. The standard model struggles to explain the sheer scale and the intricate networking without maybe invoking some extra ingredients or processes.
I see. So the universe looks almost too structured for such a simple beginning. And then, of course, there's the big mystery. Everyone talks about dark matter.
Precisely. Dark matter is essential, gravitationally speaking, for holding these large structures together. We know it's there, but its distribution, how it clumps, how it interacts, its fundamental nature, it's still a huge puzzle. And how it fits into this vast cosmic architecture, stabilized across billions of light years, isn't fully explained or integrated into the standard Big Bang picture either. These aren't just minor quibbles. They're fundamental questions suggesting maybe we need a different starting point, a new paradigm.
Okay. So what if that story we've held on to for a century needs, yeah, a radical upgrade? What if the beginning wasn't one big flash, but something more distributed, more dynamic, maybe even ongoing? This leads us right into the core idea of the Coherence Emergence Event, the CE itself. This sounds like a complete redefinition of cosmogenesis.
It absolutely is. UCTE is laid out in that first paper. It flips the script. It proposes that space-time itself, the fabric of reality, doesn't emerge from some initial singularity, that infinitely dense point in the Big Bang model.
You're right, no single point source.
No. Instead, it suggests space-time is the result of a structured crystallization. Crystallization of coherence from what Lilien calls a hyperdimensional invariant substrate.
Okay, crystallization of coherence. Let's break that down.
Think of it less like an explosion and more like, say, ice crystals forming in water. Order emerging from a background potential. And
Sure.
critically, our universe isn't the product of one such event, but potentially millions of localized coherence emergence events, or CEEs. These happen across a much larger pre-existing cosmic medium.
Millions. Wow. Okay, so not one giant firework display, but maybe countless tiny, perfectly timed sparklers, maybe,
Yeah.
all contributing to the whole picture.
That's one way to think about it, yeah. Each CEE creates its own distinct cellular universe. A little bubble is space-time. And these bubbles exist within a larger nested sort of hyperfractal lattice. Imagine a foam, maybe, but structured fractally. And these events aren't random. They're driven by something called resonance point dynamics.
Resonance points.
Yeah, these arise from the coherence vacuum. We'll get into that. And they organize along coherence gradients, like flows of potential. This organization is what forms the structured regions of matter, energy, and the dimensions we experience. It's a continuous creation process, in a way.
So, okay, let me try an analogy. Instead of one huge, isolated explosion creating everything instantly, imagine millions of localized crystallization events, like freezing points appearing in supercooled water, but perfectly timed and structured. And these events together form the very fabric of our reality, almost like individual cells growing and dividing to structure a complex organism.
That's a very good analogy. And it's one that becomes even more central when we bring in the second paper, the MBE.
Right, the multicellular organism idea. But let's stick with the foundations from CE for a moment. We need to nail down these pillars. First up, hypergravity invariance. That sounds incredibly fundamental, almost like a meta law of physics.
It is presented as exactly that, foundational. It's defined as a pre-space-time constant. Mathematically, H equals constant for all potential fields within the overarching set. What that really means is it's this irreducible, unchanging principle that organizes how structure emerges across all scales.
So it exists before space-time.
Yes, that's key. It precedes space-time. It acts like this still point, the anchor around which all fluctuations, all emergence happens. It ensures the underlying coherence potential, the capacity for order, remains constant, even when local symmetries break during crystallization.
So it's not a force like gravity pushing or pulling things.
No, it's described as an invariant organizing operator. It guides the local crystallization, the forming of these space-time cells, by imposing global symmetry constraints from the get-go. This is fundamentally different from, say, standard inflation, where you have this rapid expansion basically smoothing things out after the initial moment. Here, stability and the potential for order are inherent properties baked in from the very beginning.
Okay, so it's not an active push or pull, but a universal, unchanging principle that sort of guarantees cosmic order can emerge and stick around. Like the universe has an inherent bias towards structure. If that stability is baked in, what does that suggest about the universe's ultimate fate? Does this imply a cosmos that's maybe more resilient or structured in the long run compared to, say, heat death or a big crunch?
That's a fascinating implication, isn't it? If hypergravity invariance consistently guides emergence towards stability and order, It does suggest a long-term cosmic evolution that might be quite different from simple entropic decay towards featurelessness. It points towards a universe, or perhaps a multiverse, that is inherently self-organizing, maybe even self-correcting to some degree. While individual universe bubbles, these cells might expand, collapse, or whatever, the overarching hyperfractal lattice governed by this invariance would retain its coherence potential.
Meaning it could keep generating new universes.
Potentially, yes. It implies a continuous capacity for new emergences, perhaps leading to a cyclical or recursive nature to existence on the grandest scale. This underlying resilience is a direct consequence of that invariant organizing principle.
That really reframes how we think about empty space, doesn't it? But okay, if coherence is the raw material, how does it actually build reality? How do we get from this pure potential to the 3D space, 1D time, and the forces we know? Let's talk about the coherence vacuum and these resonance points. You called them the quantum seeds of spacetime.
That's right. First, the coherence vacuum. It's crucial to understand this isn't empty in the way we normally think of a vacuum. It's described as a coherence-rich vacuum, a realm brimming with pure potential, unmanifested information, latent energy, a sea of possibility.
Okay, so it's full, not empty.
Exactly. And from this full vacuum, resonance points spontaneously appear. Think of them as discrete quantum excitations, tiny localized packets or condensates of coherence. Importantly, these exist before spacetime crystallizes. They're pre-geometric seeds.
Like the very first sparks of order.
Precisely. And when these resonance points become dense enough in a region, they drive the nucleation, the beginning of a local coherence domain. Crystallization kicks off when the resonance density, there's a formula for it, or proportional to an exponential decay related to the coherence difference, exceeds a critical coherence threshold in it.
So it's like these invisible pockets of potential energy suddenly hit a critical mass, like reaching a freezing point, and then bang, they solidify into something tangible, something structured like space-time, but happening everywhere, locally.
That's a good way to visualize it, like countless little zones reaching their freezing point independently but coherently. And what's really critical here, what makes it different from just, say, water freezing, is that this ordering arises from the alignment of coherence gradients with hypergravity invariance.
Ah, okay. It's not just settling into the lowest energy state randomly.
No, it's not simply energy minimization like in classical phase transitions. It's portrayed as a directed, guided process. This alignment between the local flow of coherence, the gradients, and the global organizing principle, hypergravity invariance, is what encodes the very directionality of cosmic emergence. It gives the universe this built-in drive towards structured stability and complexity right from the moment these crystallizations begin. It's a very elegant mechanism for generating order.
Wow, okay, that really shifts the perspective on how fundamental order arises. So let's move to how reality actually unfolds from this coherence, the structural emergence. You mentioned dimensional hyperfractal emergence. This sounds like even the number of dimensions we experience isn't a given, it's something that emerges too.
Exactly that. In UCTE, dimensionality isn't a fixed background stage. It's emergent and dynamic. It's a product of the process. It unfolds through what are called nested coherence reductions via hyperfractal cascades. Mathematically, you can think of it as a mapping VED from the coherence potential A to a manifest dimension MD.
So different parts of the universe could, in theory, have different numbers of effective dimensions based on how they emerged.
That's a prediction of the framework, yes, depending on their local emergence history. Now, people might think of string theory with its extra curled-up dimensions, but this is different. Here, the very number of dimensions we perceive are familiar 3 of space. 1 of time isn't assumed. It's a result of how coherence crystallizes and stabilizes.
So the 3+1 structure isn't fundamental, but a consequence of this deeper coherence. And does that extend to the fundamental forces too? Electromagnetism, gravity, the nuclear forces. Are they also just expressions of this coherence?
That's precisely the next step. It's quite a philosophical leap, isn't it? Moving beyond a fixed stage to reality itself being constructed. This brings us to bivectorial coherence cascades. Now, this gets a bit technical, but the core idea is the bivector coherence operator, written as B as my 402. This is identified as the very first emergent identity or structure after the fundamental hypergravity invariance.
Okay, the first pattern to emerge from the potential.
Think of it that way, yes. It's the bridge between the pre-geometric dynamics and the observable physical symmetries, the forces that we see later. It's like the initial blueprint for those forces.
And how do we get from this bivector blueprint to the forces we actually know, like electromagnetism, for instance?
It happens through a cascade. As coherence evolves and, in a sense, differentiates or undergoes coherence loss, meaning potential becomes manifest structure, this bivector structure collapses or projects into left and right-handed states.
Yeah.
These form what are called chirality fields, C. And from this differentiation, through different coherence thresholds being crossed along this hyperfractal unfolding,
Right.
the distinct gauge symmetries, which correspond to the fundamental forces, emerge hierarchically. So the theory proposes a sequence. B, the bivector undergoes coherence loss, leading to C chirality fields, which then, depending on the pathway, gives rise to U1, electromagnetism, SU2, weak force, and SU3, strong force. So yes, what standard physics treats as separate? Fundamental forces are viewed here as different manifestations, different symmetry expressions of one unified coherence cascade.
That is an incredible unifying vision. It's not a universe of separate parts, but everything flowing from this single underlying coherence. Which leads us nicely to the cellular universe model from the CEE paper and what it predicts we might actually see. How does this manifest in the cosmos we observe?
Well, the CEE model makes some pretty specific, potentially observable predictions based on this cellular structure. It estimates that our observable cosmos might contain somewhere in the ballpark of 2 to 5 million distinct cellular universe domains.
Millions of these space-time bubbles within our horizon.
That's the suggestion, each one resulting from a distinct coherence emergence event. And critically, each CEE produces a bounded space-time crystallization zone. Within these zones, the paper suggests local physical constants, things we usually assume are absolutely universal, like the speed of light c, Newton's gravitational constant g, maybe even the fine structure constant alpha.
Wait, these could vary slightly from one cell to another?
That's the implication. Subtle variations might exist across these different domains, reflecting their slightly different emergence histories or coherence states. That's a profound departure from standard cosmology.
That is truly mind-bending. Our little pocket of the universe might have slightly different physical rules than the cell next door. Okay, so what happens at the boundaries, where these cells meet?
That's where the coherence cracks come in, as described in the CE paper. They're predicted to be topological defects. Imagine trying to perfectly tile a surface with slightly irregular tiles. You'd get seams or defects where the patterns don't quite match up.
Okay, like fault lines in the fabric of reality.
Something like that.
Yeah.
They arise from incompatible lattice symmetries where adjacent emergence events, adjacent crystallizations, meet. And the CEE paper proposes initial testable predictions for these boundaries. For instance, we should look for unusual gravitational lensing effects near these boundaries. Light bending in unexpected ways because of these structural discontinuities.
Not just lensing from mass, but from the boundary itself.
Exactly. And also, we might expect to see specific kinds of anomalies in the CMB, like those cold spots, potentially corresponding to regions where coherence gradients transition sharply at these boundaries. Furthermore, the large-scale filamentary structures, the cosmic web, might actually be the network formed by these cosmic cell walls, explaining the observed distribution of galaxies and voids without needing some of the more exotic geometries invoked in certain inflationary models.
These coherence cracks sound like, cosmic scars?
Yeah.
If you could somehow travel to the edge of one of these domains, what would it even be like? A visible wall, a physical barrier, or something much weirder? And crucially, how do these boundaries, these interfaces, get even more complex and dynamic? Because that's where the second paper, Multicellular, Big Emergence, really takes things to the next level, right? This is where the biological analogy properly kicks in.
That is precisely the bridge. CEE introduces the cells and hints at the boundaries, these cracks. But MBE, the second paper, it takes that concept and injects it with dynamism, energy, and a much deeper physical mechanism. It transforms those somewhat passive cracks into active, energetic structures, framing the whole multiverse not just as a collection of cells, but as you said, a dynamic living organism.
Absolutely. So the Codex of Emergent Universes, MBE, it just runs with that cellular idea and expands it massively. It says our universe's birth wasn't some isolated thing. It was part of an ongoing cascade of big emergence phenomena, basically multicellular clusters of universe bubbles forming and evolving together, all nested within this vast, interconnected, hyperfractal omnilectic field. The scale just explodes.
It really does. Big emergence itself gets redefined more explicitly. It's the nucleation, the birth of a new universe bubble, through coherence condensation within this overarching field. And this omnilectic coherence reservoir is a much richer, more detailed concept than the simple coherence vacuum of the first paper.
Omnilectic, meaning it encompasses everything, all potential connections.
Something like that. It's the foundational pre-spacetime field from which all universes emerge. Think of it as the coherence-rich soup, or, using the biological analogy, the cytoplasm.
Ah, the nourishing medium where the cells live and divide.
Exactly, the vital potential layer in which new universes, the macrocells, can form, grow, and interact.
So the multiverse is now behaving like a dynamic coherence organism. Universe bubbles are the macro cells. This is really where that biological metaphor comes alive. We're not just cataloging separate cells anymore. We're picturing an entire cosmic organism that's constantly growing, differentiating, maybe even reproducing.
It fundamentally shifts the view from static snapshots of emergence to a dynamic evolving system. It's a living cosmos.
And if these universes are like cells in an organism, they need membranes, right?
Yeah.
Something to keep them distinct but allow interaction.
Precisely. And that's the role of the cosmic Coulomb barriers, a really pivotal new concept introduced in the MBE paper. These aren't just passive boundaries. They are described as highly energetic discontinuities in the coherence gradients. They act as phase-lock exclusion zones between adjacent universe bubbles.
Okay, so the coherence cracks from paper one get a major upgrade. They're not just seams anymore.
Not at all. They become much more robust, energetic, and dynamic. It's like going from seeing a crack in a wall to understanding the powerful molecular forces holding the wall together and defining its edge.
So these barriers are active.
Very active.
Yeah.
MBE describes them as high-tension hypergravity sheaths. The analogy used is the electrostatic Coulomb barrier in atomic nuclei. Just like that barrier prevents positively charged protons from easily fusing together.
Right, they repel each other.
These cosmic Coulomb barriers prevent the uncontrolled merging or blending of different universe bubbles. They act like sophisticated semi-permeable membranes, maintaining the unique identity of each emergent reality while allowing for interaction at a deeper level.
That's a really strong analogy. So how do they work physically? What's the mechanism keeping these cosmic cells distinct yet potentially interacting?
It comes down to the coherence dynamics again. Inside a universe bubble, the fundamental patterns of coherence through the eigenmodes evolve smoothly. Everything's in phase, relatively speaking. But at the edge, where one bubble meets the different coherent structure of a neighbor, there's a very steep gradient. The local coherence patterns just don't mesh. Mathematically, the gradient Irachek approaches infinity.
So they're out of sync.
Profoundly out of sync. This leads to phase incompatibility. The fundamental rules inside one bubble, the gauge symmetries, the vacuum constants, maybe even dimensionality might be quite different from its neighbor. Trying to cross that boundary would require a massive instantaneous resynchronization with a completely different coherence spectrum. It's effectively impossible without overcoming a huge energy threshold.
Like hitting a wall.
An energetic wall, yes. The barrier itself is described as behaving like a hypergravity attractor shell. Coherence sort of condenses there, forming a high-tension skin that stabilizes the bubble. These skins transmit coherence pressure between bubbles, allowing them to jostle, but they strictly forbid structural leakage, preserving the distinct physics inside each one.
And there's math to back this up, an equation for the strength of these cosmic membranes.
Yes, MBE proposes an effective barrier potential. It's written as VCR, is approximately kappa times delta lambda squared over r. It's analogous to the nuclear Coulomb barrier equation, but here it's based on the coherence mismatch. Delta lambda is the difference in coherence eigenvalues between the bubbles, and kappa is a coupling constant.
So the bigger the difference in coherence, the stronger the barrier.
Exactly. And any process trying to cross this barrier or seed something through it needs to have a coherence energy, eco, greater than or equal to this potential VC. So you see how those earlier coherence cracks are now given this dynamic, energetic, almost repulsive quality. It provides a really robust physical reason why these emergent universes don't just mush together chaotically. They stay distinct, phase-contained, allowing for that stable, structured, multicellular multiverse.
Okay, this brings us back to a key piece of math you mentioned earlier, the vacuum coherence tensor, the VCT. It was in the first paper, but it seems like it becomes even more central in MBE, like the master key to understanding all these dynamics.
It really does become the central mathematical framework in MBE. In CEE, the VCT, was introduced to unify the dynamics, showing how hypergravity invariance, resonance density, and coherence gradients all couple together. But MBE really emphasizes the VCT as the description of how coherence gradients behave across the entire omnilectic field, structured by symmetry. Its eigenvalue spectrum solving the equation Vemay becomes paramount. These eigenvalues E directly correspond to the coherence thresholds that determine what happens where. So the VCT isn't just some abstract math tool, it's like the operating system or the cosmic DNA that dictates. Here a universe crystallizes, here a void forms, and crucially here are the dynamic energetic boundaries, the cosmic Coulomb barriers. It maps out the whole interconnected structure. Precisely. The VCT gives you unified predictive power. If an eigenvalue OI is above the critical threshold block, you get coherent spacetime crystallization. A universe bubble forms. If EA is below lock, you get a decoherent void zone. Importantly, these aren't truly empty. They're regions where the coherence potential is too low to crystallize structured spacetime, but they're still part of the anomalistic field.
Latent potential zones.
Exactly. And the principal curvature eigenvalue, Lamax, the largest eigenvalue, acts as a key indicator. Sharp transitions in maps of OMAX directly reveal where these barrier zones are located and how strong they might be. It's like a diagnostic scan of the multiverse's architecture.
Okay, so if universes are like cells, distinct yet connected in this larger organism, do they talk to each other? Do they interact across these barriers? MBE introduces another really wild concept, entanglement bridges. Are these like hidden communication channels, cosmic wormholes for coherence?
Conceptually, you can think of them that way, yeah, like subtle information conduits. MBE proposes these entanglement bridges as thin resonance channels that can actually link otherwise distinct universes. The key mechanism is allowing sub-vacuum coherence exchange. This might potentially bypass the main phase lock exclusion zones of the cosmic Coulomb barriers.
So information or coherence could sneak through these bridges even if matter and energy can't cross the main barrier.
That's the implication. While the barriers prevent direct physical merging or travel, these bridges might offer pathways for the underlying coherence itself to flow or connect non-locally. It suggests that superluminal entanglement pathways faster than light connections might exist, but only operating through this underlying omnilectic layer, not through conventional spacetime travel. This opens up truly incredible possibilities for interbubble communication, information transfer, or correlated evolution on scales we can barely comprehend.
Wow, that really does raise the question. Could these subtle coherence threads be the ultimate wormholes, connecting vast, distinct realities in ways completely outside our current understanding of physics? And what about making new universes? If this multiverse is a living, growing organism, where does cosmic mitosis happen? Where do new cells bud off?
Right. There must be specific locations or conditions more conducive to new emergence. MBE points to two key phenomena: hypergravity attractors and quasar hypercores. Hypergravity attractors are essentially points of intense coherence concentration, regions where the influence of that foundational hypergravity invariance spikes, actively triggering the nucleation of a new emergent universe bubble.
Okay, fertile ground, basically.
Yes. And even more dramatically, quasar hypercores. Think about quasars, the incredibly energetic cores of distant galaxies, the brightest things we see. MBE hypothesizes that these hypercores reach such extreme coherence spikes, such intense concentrations of potential, that they can actually exceed the local cosmic Coulomb barrier thresholds.
They can punch through the membrane.
Effectively, yes, pierce the barrier. This could allow them to seed new daughter universes in adjacent regions of the omnilectic field.
Wow. Okay, so picture a quasar not just as a super bright galactic engine, but as a cosmic needle, potentially stitching new realities into existence, or maybe even linking existing ones in some way. That completely reframes how we see those objects. This also sounds very much like an ongoing process, not just something that happened 13.8 billion years ago. What about recursive genesis and nested time? What does that imply?
This is arguably one of the most profound and mind-bending implications of the integrated CE-MBE model. It suggests recursive genesis, meaning when a universe bubble emerges and expands the big emergence event, it doesn't just inflate into pre-existing empty space. Instead, the very act of its expansion generates new void coherence ground around it within the omnilectic field.
So the expansion creates the raw material for future universes.
Exactly. These expanding voids aren't truly empty. They are latent coherence reservoirs, effectively acting as nutrient beds for subsequent generations of emergent universes. The analogy is biological mitosis. Daughter cells emerge and grow within the shared cytoplasm provided by the parent cell and its environment.
So the very expansion of our universe, the thing we observe as cosmic inflation or dark energy driving acceleration, could actually be fertilizing the omnilectic field, preparing the ground for the birth of other universes.
That's the picture painted by MBE, yes. If you connect all these dots, it means cosmogenesis isn't a singular past event. It's an ongoing recursive process, potentially happening right now all around us, on scales we can't perceive directly.
This leads to an even wilder idea. Time itself might branch hyperfractally.
Nested time, potentially. Our universe's expansion could be creating the substrate for future bubbles, and perhaps our own universe is itself nested within the cytoplasm generated by a prior parent emergence. It portrays this vast multi-cell organism of universes evolving collectively, perhaps towards higher states of symmetry or complexity, much like biological evolution favors increasing complexity over time. It's a cosmic ecosystem, continuously creating, connecting, and complexifying.
Okay, this theory is definitely not short on big ideas, but crucially, you've mentioned it makes concrete, testable predictions. It's not just untethered speculation. So let's bring it back to observation. What are the comprehensive predictions, drawing from both CEE and MBE together? Where should astronomers and physicists actually look for evidence?
Right, this is where the rubber meets the road. And the predictions are quite specific, which is what makes it potentially verifiable science. So, from CEE, we already had predictions about anomalies in the cosmic microwave background, things like subtle ring-like patterns, coherence ripples, or scar anisotropies, appearing at specific angular scales that might correspond to the boundaries of these emergence domains. MBE refines this, suggesting that the known cold spots in the CMB could be signatures of where coherence gradients transition particularly sharply due to the stronger cosmic Coulomb barriers. We're looking for specific, non-random temperature patterns.
So those CMB cold spots, which have been a puzzle, could literally be the faint thermal echo of a cosmic cell wall. That's incredibly concrete.
It's a specific interpretation offered by the theory, yes. Both papers also predict gravitational lensing anomalies near these boundaries. MBE sharpens this by predicting non-Gaussian lensing patterns, meaning light wouldn't bend smoothly as predicted by just the mass distribution according to general relativity. Instead, you'd see unique, perhaps sharp distortions caused by the high-tension structure of the cosmic Coulomb barriers themselves.
A different kind of lensing signature.
Exactly. And the large-scale structure, the cosmic web, the filaments and voids like the Laniakea supercluster, is predicted to align with this underlying network of cosmic cell walls. Its structure should correlate with subthreshold eigenvalues of the VCT, mapping out the less coherent zones. And let's not forget the CEE suggestion of subtle variations in fundamental constants across different regions. Detecting even tiny shifts in alpha or G would be revolutionary.
Are there completely new predictions that only really come into focus with the expanded MBE picture, things unique to the multicellular dynamic aspect?
Yes, MBE adds several more layers. For instance, it proposes specifically mapping the principal curvature eigenvalues of the coherence field across the sky using large surveys. Identifying sharp transitions or discontinuities in these OMAX maps would be a direct way to locate the barrier zones, essentially, creating a map of the cosmic Coulomb barriers.
Wow, actually mapping the multiverse's walls.
That's the ambition. Another exciting, though perhaps futuristic, direction involves designing experiments to detect those intra-bubble coherence transfers via the entanglement bridges, maybe looking for faint, non-local correlations or signals that seem to violate standard physics. And on the large scale, MBE predicts that the vast voids shouldn't just be empty by chance. Their locations and sizes should correlate directly with the regions where the VCT eigenvalues are below the crystallization threshold. They are structural features defined by low coherence potential.
And how would scientists actually model all this complexity, simulate this interconnected cosmic structure?
Well, CEE already mentioned using tools like Monte Carlo simulations and finite element modeling, standard techniques in cosmology. MBE builds on that by suggesting the incorporation of specific maps derived from the theory. Barrier strength maps, calculated using that formula BOR, and the coherence eigenvalue maps, max. These would allow researchers to build much more detailed predictive models of the multiverse's architecture and dynamics, pinpointing exactly where to look for these observational signatures.
The sheer number and the specificity of these predictions, it really does elevate the UCTE framework. It moves it from being just an interesting philosophical idea to a potentially verifiable scientific hypothesis. It feels like the universe might be leaving breadcrumbs, and these papers are offering a map to follow them. Finally, to help us really visualize all this, the MBE paper apparently includes something called the codex glyphics, a way to represent this incredibly complex integrated reality visually.
Yes, and they're described not just as illustrations, but as detailed scientific visualizations. They aim to synthesize the mathematical formalism and the conceptual architecture from both papers into a single, comprehensive visual language. The centerpiece is called the Codex Glyphic Spiral Masterplate. It's designed to integrate all the key elements we've discussed into one coherent, meaningful image.
Okay, can you paint a picture for us? What would we see on this master plate?
Right. Try to imagine this. At the very center, there's the onelectic core glyph. It's shown as this central luminous symbol representing that foundational coherence reservoir, the ultimate source. Radiating out from that, you see the emergent universe bubbles. They're depicted as these expanding, glowing cells, each a distinct space-time like ours.
Okay, I can picture that.
Now, critically, surrounding these bubbles are the cosmic Coulomb skins. They're highlighted, maybe as luminous cyan or violet membranes, visually marking those sharp coherence discontinuities, the dynamic walls between the universes. And positioned at key points along these barriers, perhaps where they meet or curve sharply, you'd find hypergravity attractor glyphs. These represent those quasar-like coherence spikes, the hot spots for new universe nucleation.
The stitching points.
Exactly. And then, subtly connecting some of the bubbles, perhaps bypassing the main barriers, you'd see thin, glowing filaments, the entanglement bridges, symbolizing those pathways for shared coherence. And the whole thing is set against a background described as a layered infinity spiral, a logarithmic spiral maybe, suggesting the nested recursive nature of these big emergence cascades, giving a sense of infinite depth and the fractal topology of it all. They really are designed to help grasp the sheer scale, dynamism, and interconnectedness of this proposed multicellular multiverse.
That's quite a visual. What an incredible journey we've taken. We started with the cracks in the standard Big Bang model,
Yeah.
moved through the initial idea of separate cellular universes from CEE, and arrived at this breathtaking vision from MBE, a multicellular universe cascade, a living, breathing cosmic organism. It's a reality where space-time, dimensions, even the fundamental forces aren't fixed things. They're emergent properties born from this deeper coherence. A universe shaped by this constant dance between coherence, hypergravity invariance, and these energetic membranes, the cosmic Coulomb barriers, all unified, mathematically at least, by the vacuum coherence tensor.
And the integration of the two papers is really what gives it this depth. It shows us a potential cosmos that is just infinitely more complex, more interconnected, maybe more alive than we ever imagined.
Right.
It really invites you to see everything, every galaxy, every void, maybe even consciousness itself as an integral, active part of this immense emergent tapestry, a cosmic creation that's still unfolding.
So thinking about all this, what does it mean for you, listening right now, for your place in this potentially vast interconnected reality? Well, here's a final thought to leave you with. If our universe truly is just one macro cell in a much larger cosmic organism, and if, as Lilien suggests, its very expansion is constantly creating new void substrate, new potential ground for future emergences, what does that imply about the emptiness we see? Could that vast dark space between the stars and galaxies not be empty at all, but actually be pregnant with the latent potential for new realities? Could new universes be continuously emerging even now, all around us, in a cosmic dance of creation that never, ever truly ends?